first thing we have to do, before a horse can move properly, he has to be able to stand properly. Because when we stand, the horse, like ourselves, interacts with gravity. We have to interact with gravity every day. That interaction with gravity is what allows us to move. If we can't effectively and efficiently interact with gravity, it makes movement very difficult. The horse, being a prey animal, not only has to be able to interact with gravity, he has to be able to interact with gravity very quickly. Because if he can't in the wild, he'll end up as breakfast. So we look at Scooby here, and remember that the cannon bones are most effective when they're perpendicular to the ground. So if we ask Scooby to try to stand, we see that he really does not stand with perpendicular cannon bones. Scooby's not as bad as some horses we've seen. If we look at this picture of Fred, we see a horse that has very, very bad neurological input. Okay? The reason that we won't stand with perpendicular cannon bones is we have some sort of faulty neurological input. The brain seems to think that we're standing on a hill. Okay? Now, let's use my thigh bone, my shin bone, use my shin bone in place of Scooby's cannon bone. Okay? So, my thigh bone, my shin bone should be perpendicular to the ground. If my brain said, "Hey, Doc, you're standing on a hill, lean forward." So, my shin bones start to lean forward. All of a sudden, I have to drop my butt to catch myself from falling on my face. If we look at Scooby, his back legs are in. And when we look back at the picture of Fred, we can see his back legs are way underneath him. We like to call Fred a prime example of a goat on a rock. Okay? Very bad neurological input. Now, when Scooby stands with perpendicular cannon bones, just like when we stand with perpendicular thigh bone, we use our flexors to stand. Okay? These muscles are some of the first ones that are formed. They also have very short muscle fibers, a lot of connective tissue in them, and the energy source is stored within the cell. So very efficient. Allows me to stand here and talk to you very comfortably. When we stand perpendicular, just like with perpendicular cannon bones, we're going to use our extensor muscles to stand. Okay? These muscles allow us, they're our stabilizing muscles. They allow us to stand very efficiently. They have short muscle fibers, a lot of connective tissue in them. The energy source is stored within the cell, within the muscle cell, and so it's very efficient for me to stand here and talk to you. It's very efficient if our horse has perpendicular cannon bones for him to stand here and graze. Okay? Now, if my neurological input is bad and I have to start standing like this, I am now using my flexors or my mobilizing muscles to stabilize. Okay? This is very inefficient. If y'all do this at home, you'll start to feel a little burn here. That's from waste products. That's lactic acid buildup. Okay? There's no connective tissue in these muscles. We start to cramp up. It's very inefficient for me to move from this position. Just like when we look at the picture of Fred, you can tell that Fred can't move. I have to move to move. Okay? If I have to move twice, the lion only has to move once, I'm breakfast. So therefore, we have to be able to stand correctly. We need to stand, we want our horse to stand with perpendicular cannon bones. Square your horse up. If your horse can't square up properly, if your horse has problems squaring up, it probably means that the input from his feet or his jaw aren't correct and are telling his brain, hey, I'm standing on a hill. Okay? So, we have to be able to stand correctly before we can move correctly. So posture is very important. Yes, there can be problems with conformation, can lead to an altered posture, but those horses that have conformation problems have problems moving also. Now, next time in our second segment of biomechanics of equine movement, we'll start and we'll look at the movement of the head. And then in the third segment, we'll look at the middle of the body, followed by the movement of the rear end.